Hello, today we're going to be discussing section 10.4, which is on zero and negative exponents. Our essential question for today is how can you evaluate a non-zero number with an exponent of 0? How can you evaluate a non-zero number with a negative integer exponent? Our key ideas today. First, zero exponents. In words, any non-zero number a, such that where a is raised to the 0 power, is equal to 1. However, if we have 0 raised to the 0 power, it is undefined. So, for example, if I take any non-zero number, such as the number 5, and I raise it to the power of 0, this gives us a result of 1. And the reason this follows our quotient rule for exponents. If I had, for example, 5 to the second power divided by 5 to the second power, when I divide 25 divided by 25, I reduce this all the way down to 1. The numerator is the same as the denominator. But also, we can use our exponent rule, our quotient rule of exponents, to subtract our exponents and simplify. So I have 5 to the second in the numerator. When I subtract the exponents in the denominator, I end up with 5 to the 0. So that means that 5 to the 0 is the same as 5 squared over 5 squared, which is the same as 1. So 5 to the 0 would simplify to 1. Numerically, 4 to the power of 0 would simplify to 1, and algebraically, a to the power of 0 is equal to 1, so long as your a is non-zero. Now a negative exponent. For any integer n and any non-zero number a, where a is raised to the negative n power, a to the negative n is simply the reciprocal of a to the n power. So for example, if I have 5 now and I'm raising it to the power of negative 2, all this is saying is that in order to make our exponent positive, we need to take the reciprocal of the 5. So this is actually going to be 1 over 5 to the second power. We drop our 5 to the second power to the opposite side of your fraction bar and make that exponent positive. Another way we could see this is if I had 1 over 3 to the negative 4th power. This negative exponent tells us that that base is on the wrong side of the fraction bar, so I'm going to bring this up and multiply by what's already there. The 3 now has an exponent of positive 4, multiplied by the 1 that's already there, and in the denominator there's nothing left, so we can put a 1, or as we know, it's not necessary to write the 1. So this then simplifies down to just 3 to the 4th power. So numerically, if we have 4 to the negative second, that actually means 1 over 4 to the positive second. Algebraically, if I have a to any negative exponent, then that's actually 1 over a to the positive exponent. Again, a to the negative n is just the reciprocal of a to that positive exponent. So here are some examples. I'm going to leave everything in terms of a power. 3 to the negative 4th power. I'm going to drop that 3 to the opposite side of the fraction bar, making my exponent positive, and on top I just have a 1 remaining. To simplify in b, I'm multiplying and we have the same base, so I'm going to keep that base, negative 8.5, and simply add my exponents, negative 4 plus 4. This simplifies to negative 8.5 to the power of 0, which is just 1. In c, if I subtract my exponents, I've got 2 to the 6 minus 8 power. I'm starting with the numerator of the exponent of 6. So when I subtract the denominator's exponent of 8, this answer is in the numerator of my fraction. But I have a negative exponent, and we can't leave our expression with a negative exponent, so I'm going to simplify by dropping this 2 to the opposite side of the fraction bar and filling in that numerator with a 1. Another way that you can see this is I have 6 2's on the numerator and 8 2's in the denominator. If I cancel out all 6 2's in the top, I'm left with a 1. If I cancel out 6 2's in the denominator, I'm left with a 2. So either way we can go about it, we end up with that same 1 over 2 squared. Go ahead and take a moment to pause the video now and try these next 6 on your own. For number 1, we should have 1 over 4 squared. For number 2, I should have 1 over negative 2 to the positive 5th power. For number 3, when I add exponents, I end up with 6 to the 0, which simplifies to 1. Number 4 will be 1 over negative 3, or 1 over negative 3 to the 1st power. Number 5, 1 over 5 to the 3rd power. And 6, when we simplify this all the way down, we are going to end up with just 1 again. You can simplify number 6 a couple of ways. Since this fraction bar does group the numerator together, it's probably a good idea to go ahead and simplify the numerator first by adding those exponents. So we have 4, and then 5 plus negative 3 is a positive 2 over 4 to the 2nd power. And you may reduce straight from here, dividing to get 1, or you may subtract those exponents to get 4 to the 0, which again simplifies to 1. To simplify expressions now that are composed of a few different pieces, including a variable, we're going to go ahead and deal with our exponents first. So here I have negative 5 times x to the 0 power. So this is really negative 5 times, and then I'm going to group that x and the 0 together to make sure that I'm not including that negative 5 on the exponent of 0. The 0 is only applying to the x. So what happens is we end up with negative 5 times something to the 0 power, which would be 1, assuming that your x is non-zero. If x is non-zero, anything raised to the power of 0 is going to give us 1. So this just simplifies down to negative 5. In B, this negative 3 is only applying to the y, and it tells us that that y is on the wrong side of the fraction bar, so I'm going to drop it down to the other side where it belongs, multiplying by what's already there, and changing that exponent to positive, leaving us with 9 over y to the 8th. Another way you might be interested in doing this is looking at this as 9 times y to the negative 3rd over y to the 5th. And I can subtract my exponents here. This ends up being 9 times y to the negative 3rd take away 5. 9 times y to the negative 8th. And here we can see again, this y to the negative 8th is on the wrong side of the fraction bar. It instead belongs in the denominator. So we would have 9 over y to the positive 8th power. So either way you went about this, you would end up with the same result if you performed all the operations correctly. What's important is knowing that that negative exponent does mean that that term belongs on the other side of your fraction bar. Go ahead and take a moment to pause the video and try 7, 8, and 9 on your own. Number 7, we should have 8 over x to the positive 2nd power. Number 9, I'm going to start by adding my exponents. I end up with b to the 0 plus negative 10, which is just b to the negative 10. But this is not simplified because my exponents are not positive, so I'm going to simplify all the way by writing this as 1 over b to the positive 10th. We just drop that b to the other side of the fraction bar. In number 9, I'm going to subtract my exponents. I've got z to the 6 minus 9, but that 15 stays in the denominator. When I subtract, I get z to the negative 3 over 15. But that z has a negative exponent, so it belongs on the other side of the fraction bar, leaving me with a 1 in the numerator and 15z to the positive 3rd in the denominator. Another way you can do this one, if I have z to the 6th over 15z to the 9th, I can move that z to the denominator by making that exponent negative. And now I can simply add those exponents together. 9 plus negative 6 is going to leave me with an exponent of 3. So again, either way you choose to go about this, you should end up with 1 over 15z to the third. In example 3, we have a drop of water leaking from a faucet every second. We want to know how many liters of water leak from the faucet in 1 hour. So 1 drop is equal to 50 to the negative second liters. We want to know how many drops leak from this faucet in 1 hour. So if 1 drop leaks from this faucet in 1 second, we want to know how many drops leak from this faucet in 1 hour. Well, to figure out how many seconds is in an hour, I know that there are 60 seconds in a minute and 60 minutes in an hour. But what I'm going to do first is go ahead and convert this into minutes. So 1 drop in 1 second, so how many in 1 minute? All I'm going to do is multiply by 60 to get that 60 seconds, or the 1 minute, in the denominator. So 60 drops in 60 seconds tells us that 60 drops leak from this faucet in 1 minute. Now, if I want to know how many drops leak in an hour, what I'm going to do now is convert this into hours. So I know that 60 drops leak from the faucet in 1 minute. I want to know how many drops leak in 1 hour. All I'm going to do is multiply by 60 to convert that 60 minutes into an hour. And we find that 3,600 drops leak from this faucet in 60 minutes, or 3,600 drops leak from this faucet in 1 hour. So 1 drop is represented by 50 to the negative second liters. We want to know how many liters is that 3,600 drops. So what I'm going to do is I'm going to multiply this left-hand side by that 3,600, and I'll multiply the right side also by 3,600. So now 3,600 drops, this is the amount that leaks in 1 hour, is equal to 3,600 times 50 to the negative second liters. We need to simplify this right-hand side, so I'm going to leave that 3,600 in the numerator, but drop that 50 to the negative second to the denominator, leaving it as 50 to the positive second power. 50 to the second power in the denominator is going to multiply to 2,500. And now I can reduce by dividing by 100. And we can write our final answer of, if I move this over to the left now, 36 over 25 liters leak every hour. Go ahead and take a moment to pause the video and try on your own number 10 on your own. We can remember that 3,600 seconds is equivalent to 1 hour, as we found above. So if I know that 5 to the negative second liters leak in 1 second, then I want to know how many liters leak in 3,600 seconds. Multiplying by 3,600, I make those denominators the same. So my job now is only to simplify this numerator to determine what is that number of liters that leaks in 3,600 seconds. So over to the left, I went through and I simplified that math, 3,600 times 5 to the negative 5th liters. I dropped that 5 to the denominator, making that exponent on the 5 positive. Multiplying together, I got 3,600 over 5 to the 5th power liters. I multiplied out that 5 to the 5th power and reduced my fraction to find that 144 divided by 125 liters of water leak every hour. You may, of course, divide this out to get a decimal if you'd like. I chose to leave it as an improper fraction. That concludes our lesson for today. Thanks so much for watching. Have a great rest of your day.